Hello there, Nareg is here. Today I'm gonna solve the first exercise from the first session 2018 chemistry. It's an exercise related to the part related to atoms. So let's start. Potassium. Potassium K is a chemical element that is oxidized rapidly in contact with air and reacts violently with water. It is often kept immersed in oil. Some chemical fertilizers contain potassium element in the form of many salts, such as potassium chloride, KCl. By referring to the text, justify the storage of potassium in oil. Very simple. You simply have to say that K, which is the element, in this case, it can be oxidized rapidly when in contact with air and reacts violently with water. That's why it needs to be conserved immersed in oil. The relative charge of the electron cloud of potassium atom is equal to 19 minus. Deduce the relative charge of the nucleus of potassium atom. So, in order to know the relative charge of the nucleus, you have to say that the atom of potassium is neutral, electrically neutral. That's why the nucleus and the cloud, the electron cloud, both have the same charge, but of course opposite. One of them is 19 minus, the other one should be 19 plus. So this is how you can say that this is 19 plus, simply because it's an atom, it's not an ion. So whenever you have an atom, the whole charge of the atom is 0, it's neutral. Show that the atomic number of potassium is 19, knowing that the relative charge of the one proton is 1 plus. So you can say that the charge of the nucleus, Q of nucleus, is actually equal to Z times 1 plus. So we have, in this case, 19 plus is equal to Z times 1 plus, or 1 plus. So I can deduce that Z is equal to 19. You have a certain number of protons, which is Z times 1 plus, it will give you 19 plus, so Z is equal to 19. Document 1 represents the schema of the transfer of an electron from the valence energy level of potassium atom to that of chlorine atom. By referring to document 1, answer the following questions. Indicate the valence of chlorine atom, Cl. The valence. In order to find out the valence, you need to check the Lewis representation of Cl. It has actually one electron, which is celibatary. So what I can say that the valence will be equal to 1. You have one electron which can be shared, or it can be lost, or you need to gain one electron in order to obey the octet rule. So that's why the valence is 1. Specify the column group to which chlorine element belongs in the periodic table. In order to find out the column or the group, you need to check the number of electrons on the peripheric energy level. So we have for chlorine 2, 4, 6, and 7. We have 7 peripheric or external electrons on the external energy level. So it will be, the column can be 17, or the group can be 7. Identify the type of chemical bond in potassium chloride, KCl. They already said that there is a transfer of electron. So K is losing one electron and Cl is gaining that electron. Both of them are, of course, one of them is losing, the other one is gaining, just to obey the octet rule. So you will have K transformed to K plus ion, and Cl will be transformed to Cl minus ion. So we will have a mutual attraction between them. The bond will be ionic. You will have an exchange of electrons, so the bond will be ionic. All right, so this is an ionic bond simply because you have an exchange of electrons. Potassium and chlorine gas react to produce potassium chloride KCl according to the reaction represented by the equation given below. 2K plus Cl2 gives you 2KCl. Verify using oxidation numbers that the reaction between potassium and chlorine gas is an oxidation redox reaction. Given the oxidation number of K in KCl is equal to +1. So I'm gonna take this equation and we're gonna solve it together. So 2K plus Cl2, it gives you 2KCl. So we need to check the number of oxidation for each element. For K it's 0, Cl2 again it's 0 because it's purely chlorine. K, in KCl it was +1. In Cl, Cl will be automatically -1 because you need to have +1 -1 is equal to 0 in order to have KCl as a neutral compound. So, as you can see, for K, the number of oxidation is increasing, so you need to talk about a certain oxidation. As for the second part, for chlorine, number of oxidation is decreasing. The number of oxidation is decreasing, so you have a reduction. Since you have oxidation and reduction in the same equation, that's when you can talk about oxidation reduction reaction or redox reaction. So that's all for this exercise. I'm going to ask you to subscribe to my channel because I'll be uploading new material, new videos where I'll be solving other sessions. You'll be notified. I can also share with you my Instagram and Facebook account. You can contact me directly or you can simply leave a comment below. That's all for this time and see you later.